Finally tonight, a new era in astronomy. NASA releasing a full batch of images and data from the massive James Webb Space Telescope, providing a first look at the cosmic mysteries yet to be untangled by the largest and most powerful space observatory. And who better to help us untangle this tonight than America's top astrophysicist, maybe the world's top astrophysicist, Neil deGrasse Tyson, joining us right here in person. Neil, thanks so much for being on Top Story.
Let's do this.
I know this is your world, and I want you to walk us through this.
It's our world.
It's our world. Okay, so let's start with this one right here. Talk to me about what we're looking at.
Your image is changing every 5 seconds here.
So I'm going to ask our great director, Brett, just to kind of freeze on one, and I think we'll start with one of them here.
Okay,
what are we looking at here?
This is the remnants of a star that has died. The sun will have a fate such as this, where at the end its outer layers of gas will escape into space and slowly drift away. It makes for spectacular, beautiful imagery of when this happens. And
when
these are called planetary nebulae.
What did you think?
Oh, I'm thinking, oh my gosh, we are seeing things better in more detail than ever before. Not only nearby, but far away.
So the red is gas, and the middle is
all this
star?
is gas.
Okay.
This is a star that has released this gas into space. But it's called a planetary nebula. It has nothing to do with planets. It's a historical error, actually. But these objects are all over the galaxy, and this is an example of what the telescope can do. All of the structures that you can see all throughout.
Let's see another one of these beautiful images that we've seen from this telescope, and you can walk us through it. This was the original. This is the original. So this was your favorite because it got a little bit of criticism. Some people were like, "This is it. This was the first one. It wasn't me." But some people.
Bring it on.
So tell me what we're looking at here.
Okay. So first, we are looking past several stars sitting on our nose in our own Milky Way galaxy. These are the spiked objects that are here. Ignore them.
Okay.
They're just in the way.
Okay.
All right. What we're actually looking towards is a galaxy cluster halfway to the edge of the universe.
Okay.
And it has a very strong gravitational field surrounding it. Meanwhile, galaxies behind it, these that are curved into arc shapes, they're light passing through the universe, minding its own business. It sees this distortion in the fabric of space and time, and it curves in response to it. Einstein predicted this.
There could be planets. There could be another sun,
these are entire galaxies of commensurate rank and privilege, such as what the Milky Way is.
And we can't even count them.
And this is and you know how big this is on the sky? If you take a grain of sand and hold it at arm's length, the patch of sky covered by the grain of sand is what you see here. So this is just stupefyingly detailed.
I want to keep feeding this. Give me another image here. We can't stop this. Come on. What else do we have here next up? Let's see what we're seeing here. This is a beautiful one. This is the Carina Nebula.
Once again, the stars that are nearby. By the way, these spikes occur because it's called diffraction spike. Light, as it passes through the spider mounting of the secondary mirror, diffracts around it. So there's nothing cosmic about that. It's a hardware artifact within the telescope.
And then this
is an actual gas cloud, and because the telescope is tuned for infrared has good penetration depth into gas clouds. By the way, it's the same reason why your fog lights on your car are more red and amber than blue. The more red you are into the spectrum, the deeper into clouds you can penetrate. And when you do that, you have access to places where stars are being born, as well as planetary systems around them.
Are these colors enhanced at all by NASA, or is this what the telescope is seeing?
Okay, you want to go there? We'll go there. Let's do this.
Yeah.
Okay, so in your eye, you have red, green, and blue RGB sensors in your retina. And what happens is, what we define as visible light is the light that comes through and is detected by these three. Those get combined into a single color image of what you see in your brain.
Okay.
Now, think about that. This entire telescope is tuned for the infrared. You can't see infrared.
Okay.
But what the telescope does is it can take images in 3 different bands, separate bands of the infrared. Then you hand it an RGB and create a color picture, which is the color you would see if your eyes could see infrared. So it's authentic and legit.
We thank you so much for joining Top Story tonight. This last one, we get 10 seconds.
Okay, this is Stefan's quintet. 5 galaxies go bump in the night. I don't know if you knew that.
I thought there was no sound in space.
Thanks for watching our YouTube channel. Follow today's top stories and breaking news by downloading the NBC News app.